Thank you very much for this nice introduction. I'm very sorry, ich spreche nicht good Deutsch. I learned German at school for 7 years, so that means we are very bad in teaching German in France. That's what I can say. So, when you ask me to talk, first of all, I would like to thank you very much for your kind invitation. This is a wonderful place. I've never been there before, and I loved it very much. When you asked me to talk about the female brain, I said, well, wow, that's a very large topic, so what can I say in 45 minutes about this topic? So I choose to talk about the structural and functional differences between men and women regarding brain functioning. So my conflicts of interest, what I will say in 45 minutes. So there are two things. Sex, which is related to chromosomes, XX and XY, and gender, which is more socially constructed and which is very different according to different cultures and environment. Sex means biological differences between men and women and related to chromosomal and physiological characteristics which are different but do not differ very much, sometimes a little bit, but not very much across different cultures. So, concerning, I don't know if there is a mice, something to point up? Black?
No, white.
Laser, okay. So, we are coming from here with bipotential gonads, and in a passive way, you become a woman. In a more active way, in the presence of the Y chromosome, and under the influence of the SRY gene, you have two things. First, masculinization, and second, and at the same time, defeminization. So testosterone is produced by the testes and is associated to masculinization. So there is a peak before birth in men, and right after birth, and then it's quite until puberty. And you can see nothing concerning women. And defeminization is also under the influence of the testis or the cells, the Sertoli cells, which secretes the anti-Mullerian hormone, and both lead to men, and if you have not that, you become a woman. So this is the peak of testosterone right before birth. And then we have a lot of gender differences which are socially constructed, and it's very hard to disentangle the differences between what is related to gender and what is related to sex and physiological difference. And you'll see at the end of my talk, but it's quite difficult. So, some common beliefs. Usually, I love chocolate. Fantasies, shopping, and this is just common belief. And what about men? Sex, sport, power, beer, and things like that. There is another exercise. If you give a mission to someone, go to this shop, whatever you want, and buy a pair of pants in blue males. It takes 6 minutes. It costs $33. For women, it's more complicated. It makes 3 hours and 26 minutes, and the cost is $876. And this is also the difference. When we look at us in the mirror, even thin female, they think they are fat, and all fat male think they are very thin. And this is the bathroom, his and hers. And lastly, this is the communication between men. And this is communication between women. There are so many things that are taken into account before you can speak between women. So now coming to more serious thing. In the first part of my talk, I will talk about neuropsychology, so about brain functioning, seen from the side of a neuropsychologist. And this is difficult to say if it's sex or gender difference. This study was conducted in a college. The mean age was 14 years old, and this is anxiety. You see that anxiety is higher, significantly higher, is female as compared to male. Language performances are a little bit higher in females as compared to males. Concerning mathematics, no difference. Concerning sciences, women were a little bit better as compared to men. So this is the opposite of what we usually think about women in science. So that might be related to gender. And there is also an interesting thing. If you ask men and women to self-assess their IQ, if both of them have 100, female will say I have 90, and men will say in average I'm 110. So even there we are different. Then we have also huge differences in terms of the prevalence of mental disorders. And we don't know if it's related to sex or gender. In blue, it's mainly for men. The ratio is higher in men for autism, ADHD, dyslexia, stuttering. So all these neurodevelopmental diseases are more prevalent in men. In women, emotional disorders. They are mostly emotional disorders. They start after puberty. In males, it starts earlier, even before puberty. Anxiety, depression, PTSD, eating disorders are much more prevalent in women. And again, schizophrenia, which is considered now as a neurodevelopmental disease, you have less schizophrenia, a less severe form, and with a later onset, it looks like we are protected because of our estrogens until at least menopause. And in men, early onset and more severe schizophrenia, more severe Tourette syndrome also. But there is one disease which is in neurology more frequent in women. It's about multiple sclerosis. But multiple sclerosis is much more an autoimmune disease, and autoimmune disorders are much more frequent in women. Just like you said, because we have 2 X chromosomes, and we have a double expression of immunity, so we are better in struggling against infections. So we got less severe form of disease, but more severe form of long COVID, because after that, the system is still working and it becomes something very bad with autoimmune disorders and a lot of long COVID. So it's good and bad at the same time. Concerning personality, you know, you've probably heard about the big 5 personality traits, which are extraversion, decreased in female, creativity, openness, supposed to be the same in males and females, agreeableness, which is supposed to be better in females, conscientiousness, which is much better in females. We can see that at school especially, and neuroticism, which is much, much more frequent in women with anxiety, depressive disorders, and so on. But do male and female differ in cognition? They do differ in certain aspects which are important, which were important in the prehistoric time, especially. It's about spatial cognition, which was important for survival during prehistoric time, and language, which was also important, but for women, for community care and everything during prehistoric time, and then probably about emotion. So, what do we know? There are 3 domains concerning spatial cognition. The most important difference is observed with mental rotation, and then visualization and perception. Mental rotation, the task is to maintain and manipulate a visual image, which is this target, in your working memory, And the shapes here only differ in rotation angle from this target shape. And among these, which one? There are two that are similar, but only differ in terms of rotation angle. Did you get that? So the right answer is 1 and 3. Men are better than women, usually, for mental rotation, and the D Cohen factor is around 0.5, which means moderate to high difference. Then, concerning visualization, we know from a long time, and this might be a common belief, but this is also observed when you perform tasks. Males are different from women in terms of navigation. They use this distance, direction, geometric shapes for navigating. We use landmarks, and males are usually better than females with the pool effect size, which is moderate and almost inexistent in children. So it seems that it comes after, the difference comes mainly after puberty, might be because of testosterone. And then the last one, perception. We can study that with line angle judgment. This is this. You are asked to match these two angle lines with these 11 lines in a semicircle separated 18 degrees from each other. So did you have the answer for these two? Okay, so this one is 5, and this one is 10. And usually men are better than women with the D factor of 0.57, which is moderate to high. And when you have a big sample, it's around 0.44, but only if people are over 18 years old. So it seems that it's becoming different when you grow up. And finally, the perceptual speed. It seems that we are better in perceptual speed. It's the ability to quickly and accurately compare letters, for example, here's D and D, or numbers or objects or pictures simultaneously, like here, or one after the other, or with a remembered object. And women are quicker than men in this task, usually. Now coming to language. Girls, women have better verbal abilities, an earlier onset of fluent speech, early use of complex grammatical construction. But when you are adults, men and women are equal in terms of vocabulary or verbal reasoning, which is very efficient in everyday life. Females are better than males in terms of verbal memory, which is to recall a list of words, which is very efficient for shopping, for example. Females are better than males in terms of verbal fluency, but the D value is not so high. Verbal fluency is to generate a list of words beginning with the same letter, like P or F, or belonging to the same category, for example, fruits or animals, or association of synonyms. So we are supposed to be better than men in this task, which is not very useful, but this is the case. Females are better than males in terms of semantic decision task. If you hear a verb, you encode its meaning, which might be useful when you take notes, for example. And women are faster and better in taking notes, for example. But there is an important role of testosterone in this task. For example, if you take boys and girls with congenital adrenal hyperplasia, which means that women have a higher level of testosterone and males have a lower level of testosterone, is this pathology for adrenal origins. And in this case, girls have better spatial ability than control girls, and boys have reduced spatial ability than control boys. And if you take hypogonadal males, for example, with Kallmann syndrome, they have lower level of testosterone. They have also poorer spatial ability as compared to control. So it means that an optimal level of androgens seem necessary for the expression of spatial ability. So this can be related to X and Y chromosomes. Increased testosterone predicts also lower performances in vocabulary in boys, as well as language performances. And if you give testosterone to female to male transsexual, it decreases verbal fluency skills, which is in favor of the role of testosterone in language performances, and which means that the less you have, the better are your language performances. What about emotion? There are two aspects, perception and processing. Perception. It seems that women are better in terms of perception of emotion, but not everywhere. Women are better in decoding emotions in many studies, but the difference is small to moderate. And it depends on the kind of emotion. If the emotion is simple, prototypical, women and men are equal. If emotion is less intense or less prototypical, it seems that women are better than men, probably in relationship with the fact that they have to take care of children and they have to be very attentive to the different kinds of emotion in children, but that's only an interpretation. Concerning processing, it depends on how you measure it. Empathy is the ability to detect the emotional experience of another person. And if you are very good at empathy, you are supposed to be less aggressive because you think, if he will do that to me, that will be very painful, so I won't do that to him. So empathy is good in terms of social life. Empathy, when it assessed subjectively, which means what do you think about your own empathy? Women think that they are much better with a very high D, which is 1, but it might be a stereotype. When it's assessed objectively, for example, you ask people about the emotion expressed in photos or video clips or other faces, the difference is much more modest. So, are there brain structural differences between men and women? And the answer is yes, at least for the total brain volume. Total brain volume is higher in male as compared to female, and it increases from birth, 6% different, to 11% in adulthood, with an effect size which is very important too. So male have larger brain as compared to females. It remains larger after body height is adjusted for, and female reaches maximum brain volume about 2 years earlier than males, but it's mainly because puberty is earlier in males, in females as compared to male. And what is intriguing is that the total volume, brain volume differences exist, but it's smaller than the difference in terms of heart, lung, liver, pancreas, kidney, and even thyroid, which are also bigger in men. But we have more gray matter in this smaller brain, which is good for us. Our gray matter volume to white matter volume is 5.5% larger in females. But it's largely eliminated when you adjust for total brain size. And it seems logical because larger brains, of course, need larger caliber and more heavily myelinated axon to transmit action potential across greater distance. So it's just a matter of distance, probably. Testosterone may play a role also. If you give testosterone to female to male transsexuals, it decreases great matter volumes, especially in language areas, but at the same time, it increased functional connectivity between these two areas, and I will come back to that at the end of my talk. And in women, it's a little bit more tricky because estradiol during pregnancy may decrease. We have higher levels of estradiol during pregnancy, but they decrease great matter volumes. And after birth, after delivery, they increase again, but not necessarily in the same areas, which means there is a lot of plasticity around pregnancy in women. What about cortical thickness, which is a distance between the pia matter and white matter? So the mean cortical thickness is larger in females as compared to male, and doesn't vary very much with brain volume, but the thing is that if you measure it with MRI, you show differences. If you measure it with post-mortem studies, you found a greater thickness in males. So it might be linked to testosterone, and we don't know what is the exact answer. What about cortical and subcortical sides? Because the total brain volume is higher, is larger in men. So we should expect that it's the case for every cortical and subcortical brain structure, but it's not so clear. In some studies, they conclude that cerebral white matter is larger in men, hippocampus, which is important in spatial localization, cerebellar cortex, which is important in coordination for hunting, for example, striatum, pallidum, putamen, which is also important for motor activity, are supposed to be larger in men, and some parts of cerebral cortex. But that's not, the difference is not so huge for hippocampus or caudate, for example. And when you come to meta-analysis, which is a very recent meta-analysis comparing all cortical volume differences, pink means larger in women, blue means larger in men, and yellow means no difference. So you see that there are no big differences. Maybe for frontal, sensory, motor and parietal cortex, a little advantage for women and a little advantage for men concerning occipital cortex. But when you come to adjust this for brain size, you see a lot of yellow and not much blue and pink. Maybe for frontal, large in females, and hippocampus in males, but there are no clear differences. Concerning subcortical volume differences, supposed to be a difference between striatum, putamen, maybe pallidum, and amygdala, which is involved in emotion processing, which is supposed to be a little bit larger in men. And surprisingly, nucleus accumbens, which is very much linked to reward process, is supposed to be larger in women. But you see a lot of yellow and as many blue than pink figures. But you talked this morning about artificial intelligence. And there are several studies which have succeeded in predicting if you belong to the male or the female category just on the basis of brain structure differences with an accuracy between 70 and 93%, even after correction for age or brain size. So maybe the computer is clever than we are at making a difference between both brains. Finally, there is a very small structure, part of the anterior hypothalamus, which is very much involved in the secretion of different hormones and which is located here. And this is supposed to be larger in males as compared to females, and it might be related to behavioral function and maybe sexual function. There was a huge debate for those of you who were born in 1991, like me, for example, and there was a huge debate. I think this paper was published in Nature by Simon Levet, and he reported that this structure was smaller in homosexual, and that was the first study trying to find differences between homosexual and heterosexual men at that time. And this was not replicated 10 years later. And in transgender women, there is also a decreased volume of this structure, but that was also in a small sample. Oh, I thought something was missing, but it's not the case. And maybe there are differences between men and women, but the question is the organization the same or different? In terms of lateralization and inter-hemispheric connection. In terms of lateralization, men are supposed to be more lateralized, and this was a meta-analysis from Iris Sommer, showing that there are more left-handed males as compared to women, which means that there is a reduced dominance in women, which is related to corpus callosum, anterior commissure, and mass intermedia, and I will come back to differences between this structure. It is the case. You can see that there is not a huge difference, less than 1% when adjusted for brain size, but there are much more studies showing a larger corpus callosum in females as compared to males, which means higher interhemispheric connection. Same thing for anterior commissure. Women have larger areas compared to men, but again, small difference. You can see yellow, no one, larger in females in pink, and larger in male in blue. And lastly, the mass intermedia, which is the connection between both parts of the thalamus, the left and the right part. But this is very strange because there is no interconnection at all in 2 to 25% of healthy brains. So you can survive without any interhemispheric thalamus connection. But if it's absent, it's associated with a greater incidence of schizophrenic disorders in both men and women. But it may simply reflect global brain atrophy and nothing more. We don't know exactly what is the role of it. What about brain functioning? Again, spatial cognition, language, emotion. You will see that not much differences. Mental rotation, yellow means nothing. No difference. No difference again concerning spatial skills, visual perception, visualization, perception, no difference in terms of functionality. So we can see something when you ask them to complete a task, but functionally with MRI we can't see any difference. Concerning language, concerning lateralization in language, even if men are more frequently left-handed, there is no larger asymmetry in males or in females with brain imaging. Concerning verbal generation, you see that no difference. When participants are presented with nouns, give and should give for each one an appropriate verb, so like building a sentence in a certain way. Verbal fluency, women are better, but there is no difference in terms of functional activation. They have to produce as many words as possible, for example, fruits or animals, in 60 seconds. They are much better, but no functional difference. Same thing for verbal working memory, taking notes. No differences in adults or even in children. Concerning lateralization, the planum temporale, which is a key structure for Wernicke area, one of the main structures involved in language, again, there are no significant differences between men and women. But a recent study of 2,300 young adults found significantly lower planum temporal symmetry in women, which is in favor of less lateralization. Concerning emotion processing, and again, functional MRI, no difference. If there is any small difference, it might be in pink for amygdala, but there are only 2 studies showing something in favor of amygdala in women. So nothing very clear. So now coming back to inter or intra-hemispheric connection, dominance, lateralization. Now we have tools to measure what we call brain connectome. And do they differ between men and women? And yes, the answer is clearly yes. In blue, here, you have intra hemispheric connection, which means that inside the brain, inside the left brain and the right brain, there are much more connection in men than in women, which is very useful for perception and coordination of action, which means, again, hunting. And in orange, you have a lot of inter-hemispheric connection, and women have much higher levels of inter-hemispheric connection, which is very useful for analytical and intuitive mode of reasoning. We can see that in the everyday life. We don't like to see the paper which explains in 3 pages how it works. We try it intuitively, and usually it works, and we are very different as compared to men for that. So we are supposed to be much better in the analytical, intuitive modes, and a little bit, and men are better in terms of perception and coordinated actions if we refer to higher level of intra-hemispheric and inter-hemispheric connection. And again, you can see red means females have a higher level than men, and in blue, males have a higher level than females. And again, coming to coordination, you can see that the level of inter-hemispheric connection is higher in males only for cerebellum, which is very important for coordination of movements, and it's higher everywhere else, especially in the cortex, which is associated to the association cortex, which is associated to the way of thinking, reasoning, etc. We have a high level of inter-hemispheric connection. And then a few words about biochemistry of the brain, especially the stress, cortisol, dopamine, and sex-gender effect. So if we come to sex, females typically have higher levels of cortisol than men. The adrenal gland, which produces cortisol, is larger in females than in males, probably related to the fact that we produce more cortisol. And compared with males, we have an increased response to fear and stress, but not all kinds of stresses. Women are more prone to secrete cortisol in response to social rejection, while men are more interested they more respond to stress when stress is related to power, to competition, for example, during a job interview. So this is more related to gender. Societal gender roles often result in women facing more stresses than men. If you consider sexual trauma, the fact that they have, in average all around the world, less income, lower social status. But men tend to respond to more stresses which involve achievement pressure, such as job interview, where women may find interpersonal conflicts more stressful. So we are more sensitive to stress, but very different stress, and not stress related to achievement pressure. So boys are educated to be more active, self-centered, autonomous, and girls are more educated around the world to provide care to others, are less valorized for autonomy. And this social interaction can be translated by epigenetic mechanism, which means they not change the DNA structure, but they change the way the DNA is expressed in RNA, and then in proteins, and then in organs, etc. And it may interact with hormones or neural functioning in the very early childhood, and may result in differences in brain at adulthood. So this is just a question. I leave it to you as a question. And just a few words about dopamine, because dopamine is the key thing, the key neuromediator for reward. And we know that men like to take more risks as compared to women, and they like to use more often illicit substances. Probably it's related because to their reward system, and the level of dopamine in the synapse is higher in males as compared to females. And in addition to that, in women, it depends very much on if puberty is there, if menopause is there, and on the menstrual cycle. For example, when the level of estradiol is low, dopamine is low, so less reward. When the level of estrogen is high, the level of dopamine is higher, which means higher reward in this phase of the menstrual cycle, which is very often used for prostitutes, for example. They think they are better in this phase of the menstrual cycle. Same thing for dancers, for example. They think that they are better in this phase for this and other reasons. So this is known, but we didn't know that it was related to hormones or things like that. So in conclusion, biological and physiological differences are related to chromosomal differences, and they play a role, especially hormones. There are differences in prevalence of developmental in boys versus emotional psychiatric disorders in girls after puberty. There are also differences in terms of physical aggression, which was used to be more frequent in males, even if things are gradually changing, or cognitive tasks such as mental rotation ability. And in total, 85% of sex or gender, we don't know exactly differences, exhibit effect sizes smaller than the 0.35, which means moderate differences, even for spatial cognition, language, emotion. For brain structure and function, there are more similarities than differences between men and women. Male brains are structures to facilitate connectivity between perception, cerebellum, and striatum, and coordinated action related to cerebellum. And female brains are designed to facilitate communication between individuals and between analytical and intuitive processing modes. So they have a brain which functions differently. Probably it could be related to social role, societal role, or societal role could be related to the fact that their brain functions differently. I don't know in this circle which is related to what. It's very difficult to conclude. Brain neurotransmission is differently regulated by hormones. We clearly saw that with some example, which may in turn contribute to different behaviors. And finally, stress and dopamine response are different between men and women, which may also play a role in terms of the difference in prevalence of mental disorders. Dankeschön, vielen Dank, and I can't resist to invite you to our next World Congress, which will be held in Bangalore, India, around the next International Women's Day in March 2025. Thank you very much for your attention.